Right, in 522 practice, the first set is just classifying and balancing. So, just use your clues here. If you have two sets of ionic compounds that are just switching places, that's a double replacement. If you look for oxygen as a reactant, that's going to be combustion. So let's find one of those. So here's like number 11. That's going to be combustion. Single replacement will either have one metal plus an ionic compound or a halogen plus an ionic compound. So if you can find one of those, like number 3. So there's only one metal and there's a pair here. Remember, the metal can kick out one metal and then it's by itself. So that would be single. And then here's an example number 5 of a synthesis, because you're taking two things and making it into one. I don't think there's any in this set, any decomposition. So just by chance, there's no decomposition. All right, now in the second set, it's a little more challenging. But the nice thing is that they're telling you this is synthesis, so you should know what to do. You're going to combine them. So all of these are going to be combined. Now, the part that most people get incorrect is you can't just do this. NaO2, MgF2, NaCl2, etc. That is not the right formula. So what you need to do is you need to look at the charges and consider the charges when recombining. So sodium as an ion is a 1 plus, and oxide as an ion is a 2 minus. Now a lot of people are like, well, what happens to this 2? Well, remember oxygen when it's by itself is diatomic, so that means it's going to have a 2 as a subscript, but when it becomes an ion, it's just oxygen by itself 2 minus. So if we do a crisscross, we get Na2O. And then you would balance it. So we have 2 here and we have 2 here. If we put a 2 in front of this, you'd get 2 oxygens, like over here. And then you would put a 4 in front of that, and now I'm balanced. But you can't just simply put them together on this side. Sometimes you get lucky, it's correct, but not always. The second set decomposition, I would definitely check out your 5.20 notes because it has lots of examples to help you. So meaning if you go on that slide, like carbonates, this is what it becomes. Hydroxide, that's what it becomes. Chlorides, that's what it becomes. Like the first one is just two, you don't have carbonate or hydroxide. This is carbonate, that's hydroxide, that's carbonate. So I'll do a couple of them here. Number 6 is just breaking it down. So breaking it down to aluminum and oxygen. When you're breaking it down and you are writing a metal, it's always just going to be what you find on the periodic table, Al. Remember, you're not going to put a 2 there. That 2 is from the oxygen or oxide ion, and when it's elemental, it's just going to look like that. The only ones that are going to have 2's next to them is have no fear of ice cold beer, those 7 diatomic molecules. So when I write oxygen, I will write it like that. Let's see, we'll do, let's see, so a carbonate, let's see, we'll go back to here. So if I have a carbonate, what's going to happen is I'm going to end up getting a metal oxide and carbon dioxide, and metal hydroxide will give you a metal oxide and water. So let's do this one here. So this is a little tricky because, let's see, so what do we say? The oxide of the metal. Now, hydrogen is acting like a metal. All right, and then oxide, that's O2 minus. So this is actually going to become water. And then remember, carbon dioxide is the other product. This one I wouldn't expect you to be able to do probably in first year chemistry, but you might see this one in lab. So try the other two. Again, the patterns are the clues or the explanation are right here. All right, single replacement, you have to use your activity series. Remember, it's the single metal is going to replace the metal in the pair if it's higher than it. Same thing with halogens. So I will do numbers 10 and 11. Oops. So 10, let's see, we're looking at aluminum replacing nickel. So if you look at your activity series, I don't think we need that anymore. So scroll down, let's say aluminum is right here. And remember, we're seeing if it is above nickel, and it is. So it's nickel's way down here. So that's going to happen. So aluminum is going to kick nickel out. So nickel's by itself. Now, when we combine aluminum and sulfate, we're not going to just write AlSO4. We're not going to just transfer what we see from left to right because it might not necessarily be the right formula. Aluminum as an ion, these all are ions. A lot of these take place in aqueous solutions. So these are ions. Look up your aluminum and your sulfate, your charges, and if you do a crisscross, that becomes Al2SO4 3. Of course, you can balance it. Sulfate, there's 1 here and there's 3 here, so you need 3, and then 3, and then 2. That's it. Number 11, you would look at the activity of halogens. We are looking for chlorine to be above fluorine, which if you see this, chlorine is below fluorine. So this is actually not going to occur. So you get to write NR for no reaction and be done with it. And actually, I'm looking at number 12. I don't think we've done hydrogen before as a metal, so let's do that one. So we're looking for zinc to be above hydrogen. Now, in our previous activity series, it wasn't quite as easy to find this. So I like this one because the hydrogen is in there. Zinc is right here and hydrogen's way down here. So that's going to happen. That's going to work. Now, when zinc kicks out hydrogen, as you remember, hopefully, that hydrogen looks like that. It is diatomic. And then we're going to combine zinc and chloride. Zinc is a 2+, chloride is a 1-, so it becomes ZnCl2. If we go ahead and balance that, we have 2 and 2, so we're going to need 2 on this side. 2 H's, 2 Cl's, 2 H's, 2 Cl's, 1 zinc, 1 zinc. Okay. And the last couple, double replacement should be hopefully easy, because all you're doing is just switching your ions. So remember, you can only just to make it easy, let's switch your metal ions. All right. Now, I'm just going to randomly pick one. How about pick number 15? So barium is going to switch with sodium. So now sodium would be together with chloride. Now I'm going to just write NaCl right now. And then barium would be with phosphate. Now, I'm just kind of structuring this so that, or breaking it down so that, how do I arrive at these formulas if you don't remember? You need to look up the charges. Now, sodium has a 1+, chloride has a 1-, so that will become NaCl. And then barium, if you look that up, that has a 2+, phosphate has a 3-, so that's Ba3PO4 2. As far as balancing, phosphate, there's 2 of them here, so if we put a 2 here, that'll balance out the phosphate. Now we have 6 sodium chlorides, and then that will give you 6 NAs. We only have 2 over here, so 3, that's 6, and there's 3 bariums, so that should work out. If you write your formulas right, the balancing should be fairly easy. All right, the last one, combustion, it should be easy with this case because they're all burning hydrocarbons. And if you remember, if you burn a hydrocarbon, you always have the same 2 products. When you are balancing combustion reactions, you have oxygens, many sources of it. So as a strategy, I always leave that last to balance if I can. Balance the C's and the H's first. So for example, we have 1 C on each side, so that's balanced right now. We have 4 on this side and 2 on this side. So if I put a 2 here, now I have 4. I have 2 plus 2 is 4, so you need a 2 there. And then the last one, on part 6, you are looking for to translate first, and then using your notes and your clues to figure out how to predict the product. So number 23, for example, you're going to have to look this up, but barium's a 2 plus, chlorate is ClO3 1 minus. So barium chlorate, and it's a solid. When it's exposed to heat, it decomposes. So I know I have one reactant. Now, if you remember, look back at your notes, barium chlorate, this is a metal chlorate. When it decomposes, you're going to get a metal chloride and oxygen. So barium chloride. Again, do a crisscross here. So BaCl2 and oxygen. And then you would balance it. By the way, tetracarbon hexahydride, if you look at your references, it gives you the prefixes. We haven't done this type of naming yet, but we will soon. Tetra means 4, so again, tetra is 4, and then hexa is 6. This is where I'm getting this. C4H6 is the formula for that, and it's burned, so that hopefully that gives you a little clue as far as the other reactant in the products.